Well, welcome to this HMAA webinar with our guest, Dr. Paul Barber. Paul's a forest pathologist. He's the adjunct associate professor at Murdoch University, and he's also president of Trillion Trees, a not-for-profit in Perth, which so far has planted over 15 million native trees and understory to help overcome our pressing environmental problems. I'm privileged to share that journey with him, but today I'm delighted to be able to introduce Paul as joint founder and managing director of a company called ArborCarbon. For the last 20 years, they've been developing and refining techniques for precision monitoring and measuring of vegetation. And when I first saw the techniques, the equipment, and the results of this work, I was blown away. Now, I'm sure you will be too. I'd like to introduce Dr. Paul Barber. Paul.
Thank you, John. Thanks very much for the kind introduction. Thanks for the opportunity to present today. It's a great privilege to be here. I've prepared a presentation, so I'll share my screen, and let's hope this works okay. Yeah. Is that working okay? Can you see the PowerPoint?
No, not yet.
Not yet. But we'll get there. If you've just joined us, welcome. We're just sorting out our little problems, and here we go. Thanks, Paul.
All good? Okay, great.
All good.
All right, so that should be full screen now, is it?
Yes.
Yes.
Okay, thanks very much, John. Yeah, thank you for giving me the opportunity to present. The first image you see, there's an airborne image of the city of Melbourne using our ArborCarbon technology, which was a piece of technology we placed into an aircraft, a fixed-wing crewed aircraft, and I'll talk more about that later today during the presentation. Firstly, I'd like to acknowledge the traditional custodians of the budger on which we work and play in Perth at ArborCarbon. They are the Noongar people. We recognise their connection to local land and waterways and their resilience and commitment to the environment. I pay my respect to the elders past and present. Also pay my respects to the Gadigal people on whose lands I'm presenting today. I had to rush to Sydney. We also have team members who live on Bunurong, Bunurong and Kaurna people's lands, so we pay our respects to them. As John mentioned, I thought I'd give a bit of background in terms of how ArborCarbon came about and the backstory behind that. So really, it comes back to a passion around trees and my background as a young guy growing up. I was fortunate to have a father who introduced me and a mother introduced me to nature and the bush and the forest, and I learnt to really appreciate that and respect it particularly around the areas of Gippsland, where I did a lot of fishing as a young guy and exploring those bushlands. That led into a degree at La Trobe University in biological sciences, and then from there, having an interest in science, I then decided not to go down that path, but go into forest pathology, which was quite a niche area. Back then, in the early 90s or late 90s, there were a bunch of blue gum plantations being established in the Otways and the Green Triangle in Victoria. And I always thought there might be a job in that space if that industry took off. And lo and behold, after graduating in that space more in the sort of forest pathology and taxonomy space, describing fungi on eucalypt leaves and diseases associated with eucalypts, I was offered a job in Perth and came across to work on the amazing chewit trees, the Eucalyptus gomphocephala. I'd never seen a chewit tree in my life. Came across in 2003 and learned to really respect those amazing trees along the Swan Coastal Plain. As we know, endemic to that region, and only a fraction of them remaining to what there was during the original from the original extent. During my work at Murdoch University, I was introduced to a range of different sciences, including mycorrhizal, fungal science, soil science, foliar nutrition, ecology, We had some amazing people in our group at Murdoch, and I was very fortunate to travel around different parts of the world. One of the areas I discovered was remote sensing. And in 2003, I was introduced to remote sensing. Remote sensing is really the sensing of the earth or the environments using a range of technologies. I saw the power in that technology to work across, spatial and temporal scales, and bringing that together with forest pathology. I saw there was a real opportunity to make a difference. One of the things that really struck me as well, having worked in particularly around urban trees as well, was the need for some science around how to manage those trees, and particularly the health of those trees and retention of those trees. The fact is that not only in Perth but all around the world, population is growing, cities are expanding. So the population in cities is estimated to grow around the globe to about 2.5 billion people by 2050. And we know that things like extreme weather events and temperatures in cities are increasing. There's also increasing trade, and that brings with it new pests and diseases. And we've seen that with incursions not only into Australia, but also into other parts of the world. Those pests and diseases come in and pose a major threat, not only to our urban trees, but to horticulture, forestry and agriculture. And we're seeing that right now in Perth with polyphagous shothole borer. The fact is that our cities are really, the livability of those cities really depends on the quality of the green space and the canopy that resides within them. And we know that excessive heat in cities poses a great threat to the lives of our most vulnerable people, being our older and younger people in our communities. So I became increasingly concerned about not only urban planning, but the removal of trees. And you can see that on the left-hand side. So our amazing Banksia woodlands have been removed for urban development and continues to happen. And on the right-hand side, you can see a satellite image, which is a land surface temperature image of the southern suburbs of Perth. So the red pixels you see are the hotter temperatures. The blue pixels you see are the cooler temperatures. And one of the hottest locations that you can see there is the retirement village, St Ives, next to Murdoch University, which is really just black roofs, black pavers, and very few trees. So, it really struck me that we need to be doing something about how we develop our cities and also manage our green space. So in about 2009, after having worked at Murdoch for some years as a research fellow and in the Centre of Excellence for Climate Change, Woodland and Forest Health, I kept getting increasing number of inquiries to look at why the urban trees were dying around Perth, and to diagnose that, and then to prescribe treatments or to manage the health of them and improve them. That then led into setting up ArborCarbon. And ArborCarbon was never set up in 2009 to measure carbon. The name really was around the fact that there was a lot of talk about carbon, trees sequestering carbon. There were a lot of companies popping up to plant trees to sequester carbon. But really what I was seeing at the time were there were a lot of companies planting trees that were never going to sequester carbon in a really good way. They were planting trees off site. They weren't planting the right species, and they were never going to be healthy. So ArborCarbon was really about providing advice and helping to ensure trees remain healthy and thrive and survive in the future. There are 4 core values to our business, and we developed those about 12 years ago now. Partnership, innovation, expertise and sustainability, and they still are at the core of what we do as a company now. We've been very fortunate to undertake work around all parts of the globe, in most continents, and that's meant visiting many amazing ecosystems and cities and meeting some incredible people over that time. But nearly all of those projects have been focused on helping our clients and our partners improve the health of the vegetation that they manage using whatever tools they can to do so. We also established a shareholding in a company in the UK called ArborFlight, where our technology goes to the UK and the cameras are mounted in aircraft and they acquire data and push that back. And the same in New Zealand. Aotearoa, the company is called EnviroLens. So the company has changed over that time. So, you know, it was pretty much almost a sole trader operation for about 6 years. And then we started to employ people, and one of our additional directors, Dirk Hardy, came in addition to Professor Giles Hardy, who was there as one of the founders. And then we expanded and we started to develop ArborCam in 2018, and I'll talk more about that. Over the years, we've had a lot of work. So the early days of ArborCarbon were going in, diagnosing disorders, and these are just some of them that you see, different pathogens and pests associated with trees in various parts of the world, some of those in Perth, some of those in Hong Kong. Even the top left-hand side, herbicide-affected trees where herbicide had been sprayed along a railway line and completely defoliated and killed many trees. And we trialed a range of treatments to try and help those trees overcome, and you're seeing the before and after in one of those trees there. So we've had a wide range of projects, but over time, ArborCarbon has changed a lot from, you know, really a ground-based company doing a little bit of work in the sort of technology space to being largely and mostly work around the technology and the expertise. And then more recently, with the addition of people coming into our team and expanding our capability, we're getting back into that sort of ground-based work that we did for many years. So the suite of those skills, bringing them together is what's, I think, quite unique about what we do. The technology that John got excited about some weeks ago was some of the data produced by ArborCam. Now, ArborCam is a camera system that we've developed for crewed aircraft. So we do have UAVs, we have drones, we've had them and been operating them since around about 2010, 11. We were one of the first companies to use them up in the Pilbara to monitor sheet flow and riparian vegetation up in that part of the world. But the reality is that those drones now sit there and gather dust and don't really do a huge amount in our company. And that's because we've developed ArborCam. So ArborCam is unique in that it has 11 narrow and broad bands. And I'll talk a bit more about the technology in its coming slides. But those bands in the electromagnetic magnetic spectrum span the visible, the near infrared, and the long wave infrared, which is basically the thermal region of the spectrum. We also produce 3D data, so point clouds can be produced, and we don't use what most people know as LiDAR. We have a different way of doing that. And if we drop the plane down and modify the lenses in the camera, we can produce imagery down to 1 centimeter pixels from the aircraft. So we don't need drones to do that. And I'll show you some data as we go along. We do everything ourselves. We, all internally, so we don't rely on subcontractors or push data out to others to process and so on. We own an aircraft. We also lease one for our services. So the data we produce provides very detailed information on the vertical and horizontal structure, the spectral, the thermal information, and we do a lot with that. And I'll show you some of the AI outputs of that. So the combination of that and also decades of experience in a range of diverse fields enables us to provide some really key solutions to many of our clients.
Paul, I hate to interrupt, but is it possible for you to remove the reminders that you have that are appearing on our screens? It must be on your phone. You have 2 reminders which are taking up the lower right-hand side of the screen.
Okay. I just removed one. I'm not seeing the other one.
No, we're seeing, well, it's one little part on the phone. It's the reminders on the phone about your timing.
Yeah, I'm not.
Yeah. Okay, but
okay.
Sorry, if you can't, you can't. But,
Yes.
You can't sit on my laptop at the moment. I'm not showing up.
Yeah. Oh, okay. All right. That's difficult then. I keep trying to press the dismiss button, but it won't.
Yeah, Yeah,
Oh,
same
sorry.
here.
I can, what if I do
Oh.
this? How's that if I can take it off full screen? Has that worked?
No, it's still there.
Oh, right. Okay. Interesting.
Yeah. So
It's your Outlook reminders, Paul.
Oh, is it? It's not. Sorry, it's not showing up in my
Yeah,
Sorry about that, guy. Thanks, Bryony.
no worries.
Cool.
Ah,
Oh,
Is that
wonderful.
better?
Yes,
Excellent.
yeah, you've done it. Thank you. I should have asked earlier, but
No
that's good.
worries. That's fine. Excellent. Okay, great. All right.
Meanwhile, back
Yeah, I couldn't
where
see
we
that
were.
on mine.
Yes.
So
Okay.
excellent. All right. So look, brief introduction to remote sensing. Basically, you've got a platform, which it can be anything that holds a sensor or a camera. So you've got a satellite, which is a platform, an aircraft, a drone, anything that holds that. So we typically work in the crewed aircraft space that you see there in that red oval. And then you also have the data that you collect. So basically the light bounce off, the sunlight comes down, it hits the surface of the earth, it bounces back, and then we sense that with some sort of technology. In this case, it's ArborCam, or it can be a normal camera or a LiDAR sensor or something else. So we're typically working in the space of this region, in the visible region, which is around that sort of 400 to 700 nanometers, which you see with your naked eye, and then into the near infrared, which goes off into about 850 nanometers, and then off into the thermal. So those two areas there that you see in the red circles. There are many other types of technology, but these are the ones that we typically work in. And what does that allow us to do? Well, that allows us to see the invisible. So this example that you see here on the left-hand side, I mean, this is an image of the SCG in Sydney. So we started acquiring data across the city of Sydney from the ArborCam in 2018. The left-hand image you see is what we call a true color photograph or composite ortho photo. So it really is just showing us the visible region. In the visible region, that turf looks amazing, and it's a fantastic surface. Because we have a bunch of narrow multispectral bands, not only in the visible, but in the region of the spectrum that you can't see with your naked eye, we can make combinations of those different bands. And they produce different algorithms. Some of you may have heard of NDVI. So we produce a whole range of them. And one of them we produce is called the Vegetation Condition Index, or the VCI. And that's the one in the middle that you see. So you see that scaled from the highest reflectance, so the highest values of light bouncing off the turf there in the purple, where the turf's growing the best and the most healthiest, through to the red region, which is the unhealthiest or the poorest performing. So what you're seeing there, you can even see the lines underneath the turf that you can't see in the visible region. These are the lines that obviously have been marked previously, probably with lime, and it's obviously impacting the turf in some way. You can see the wear around on the north, the eastern side of the turf and around the perimeter. So it's showing us that there's something going on with the turf. It's not telling us why, but it's telling us there's an issue here. And on the right-hand side, what we have is the thermal data. And the thermal data is really picking up surface temperature, and surface temperature is very sensitive to moisture stress and things that can cause heating. So for example, in turf, there's something wrong with the water holding capacity of the soil, or there's something that's causing, or the irrigation's faulty, then we'll start picking that up in the thermal data. I've shown you a turf example because it's the easiest to see, but we use this type of data in trees, and we do it at the individual tree scale and sub-tree scale across entire cities. And in examples like Sydney, we're going across nearly 500,000 hectares, which is 33 councils, so it's a very large area. So in 2018, we started working with I would consider the thought leaders in the urban forest space. We had been working and continue to work with some amazing local government clients in WA, particularly around sort of the Perth region. But in terms of scaling and wanting to scale across, entire capital cities and beyond, then really we had to branch east, and that's where the City of Melbourne and the City of Sydney engaged our services back in 2018. We've been repeatedly acquiring data for them since then. The left-hand side there, you see an airborne image is the baseline, which is the true color photograph. But what you see in those colored pixels are the height stratified vegetation cover derived from the ArborCarbon data sets. We can stratify the height classes of the vegetation as we wish. In this case, we even produced rooftop vegetation or green roofs, and we did that for the City of Melbourne as well. So they have entire teams working on green roofs. And then we can also classify things like turf and vegetation that's not, not woody below 3 meters in height. And so you're seeing those height classes there on the left-hand side. And that's very typical. We call these standard deliverables now for all of our clients. Not only do we produce the layers, but then we can derive all the statistics of the composition across, lots, suburbs, roads, streets, different land use classes and entire cities. And that's very important for our clients. The right-hand side, you see the City of Melbourne, and what you're seeing there is the land surface temperature, and that's derived, and it's very high resolution, derived from the ArborCarbon. So we're seeing, the heat through the roads, the heat through the buildings, and the cooling effect of, things like the water and the vegetation. And the fact is that vegetation, particularly trees and large trees, provide the greatest cooling effect in cities. Then you have the shade, and it's the turf that provides the least cooling effect in cities, but still has some sort of cooling effect. The other key part for us, in addition to the data, was really about helping our clients measure and manage their urban forests. And you can't really manage what you don't measure, and that's really critical. So we'd seen a lot of local governments and state governments developing targets around canopy cover, but not really based on any solid or robust data, just really plucking figures out of the air. And so we really became passionate about using our data, providing that to our clients. So for example, you see the City of Sydney and Melbourne, where our data consistently goes in every couple of years to help them measure. And even the City of Melbourne has targets around keeping or maintaining 90% of their trees as healthy. So our question to them would be, what is healthy and how do you measure that? So we provide measures of health derived from the airborne ArborCarbon data. So it's repeatable and quantified. We started writing strategies in 2018. We developed the City of Canning's urban forest strategy. They have one of the lowest canopy covers of all the Perth LGAs. We won the state award for that one. And then we went on to write a bunch of other strategies for various clients in New South Wales, so Coringai, Lane Cove and others. And more recently, we've been writing strategies for Kwinana, Rockingham, Melville, and several others. So it's a really core part of what we do. In the strategies, we ensure that the data is utilised. We set realistic targets. We help develop action plans to ensure that they can help them meet those targets, ensure they're achievable, and they allocate the required budget to do so. It's really, really critical, and that really drives us, and we're very passionate about it. We not only work across the urban forests, but we do a lot of work across natural forests, native forests, and plantation forests as well. So what you're seeing here is one of our UAVs with a hyperspectral camera flying across the amazing kauri forest in Northland in New Zealand, Aotearoa. Those trees are incredible. In some of those areas in the Waipua forest, those trees, there are trees like Tani Mahuta that's over 2,000 years old. Now, those trees are currently threatened by Phytophthora agathodicida and a range of other Phytophthora species, moving through and killing those incredible trees. So we've been running projects over there, not only utilising our drone data, but flying entire forests with the ArborCarbon as well, and providing the tools in addition to expertise on the ground to help manage that forest. So we're working with the Tirarora group, who's the Māori group who manage and look after that forest, and working very closely with them. It's a very important and incredibly valuable forest to not only the Maori people, but all people within New Zealand and beyond. So within that forest that you see here in one of our aerial images, we acquire the data, we can delineate each of those tree crowns, and then we can benchmark not only the size of those trees, but also the health of those trees. And then we monitor those over time. And really, this is about providing the tools that they need to target their efforts on the ground and help determine whether to treat trees. So, for example, with phosphite to try to mitigate the impacts of Phytophthora and to reduce the spread. And so we do this, we do this work to facilitate the monitoring of those trees throughout the forest. And these, currently, we're looking at delineating all the trees throughout the 9 hectares of the forest using an AI approach on our data. Some of the other exciting pieces of work we've been involved in are around biosecurity. So, we are being increasingly challenged by pests and pathogens coming into our country through increasing trade. One of the ways of keeping an eye on those pathogens or looking out for them is through monitoring what they call sentinel trees. So those pests and pathogens are most likely to come through airports and ports of trade. In this example here, we ran a project with various local government, state government agencies in New South Wales, and they were looking for pine and plane trees in close proximity to the Sydney airport. One of the reasons being that they were keeping an eye out for pests like the brown marmorated stink bug, and there are other pests and pathogens that they look at those trees for surveillance and to keep an eye out for them. Now, it's a big job going out looking for those trees on the ground. Needs a lot of boots on the ground, takes a lot of time and a lot of money. So they spoke to us about our technology and said, is there another way that we could do this? We already had airborne data, ArborCarbon data over that region from previous acquisitions. So we worked with them to combine some of their data on the ground that they had of pine and plane tree locations and our ArborCarbon data, which is very rich in that sort of spatial and spectral resolution. And then we developed some deep learning models to train those models to identify pine and plane trees through those areas. And we achieved a greater than 90% accuracy for both pine and plane, which enabled them with confidence to be able to go out to those trees and look at those trees and target their efforts rather than, knocking on doors and walking the streets and taking time looking for whether those trees existed. So that was a very exciting piece of work, and we ended up publishing that work. The old school way of doing this sort of work is to have boots on the ground. And one of our team members, Dave Smith, who used to be the forest pathologist for the Victorian government for many years, he spent many years walking out looking for things like pine trees through city of Melbourne for the presence of giant pine scale. But fortunately these days, we've got other technology like the ArborCarbon technology where we can develop a different approach. So we were engaged to fly over Adelaide not so long ago, a 20,000 hectare area, and develop some deep learning models on our data to identify whether all those pine trees were. Again, with greater than 90% accuracy, we're able to identify more than 9,000 pine trees through that 20,000 hectare area. And that's enabled people to go out on the grounds, look at those pine trees. Dave's been over to train people up to identify what giant pine scale looks like, and then remove those trees and hopefully eradicate that pest from the Adelaide region. So that poses a major threat to pine plantations and the plantation forest industry, and we're very close to eradicating that by adopting that approach, which again is really forward thinking of the people who engaged us to do that work. In addition to that, we've worked with a range of our local government clients, again the sort of thought leaders and the people who are really willing to, I suppose, develop new approaches and work with us on ideas that we have. And we developed a large pest and disease or sort of pest pathogen host interaction database. And that's some of what you see here. So basically you have all the tree hosts scattered throughout the city. They're geo-referenced, and then we were able to look at a wide range of pests and pathogens that some of them exist in Australia at the moment, many of them don't, and looked at if they were to come into the city and come into the country, which trees would be at risk, and a percentage of the tree population that would be at risk. And we're currently developing spread models for some of those pests if they do get into places like the city of Melbourne. One of those being, for example, polyphagous shothole borer, which is working its way through Perth, as we know. So this data can greatly assist in early detection monitoring and really greatly assist in emergency response to those pests and pathogens, which again pose a major threat to our urban forest. This image that you see here, it's an example of some of the work we do to identify genera and species in different areas. So we've had a range of projects. So those projects you've seen about identifying pine trees and plane trees, well, that's expanded to about 20 different genera and species in one of the major capital cities in Australia across nearly 800,000 trees. So the process in doing that is acquiring ArborCarbon data. Once we acquire the data and produce our outputs, we then develop some tree crown delineation models. And you see an example of that in the center there. So delineating each of those tree crowns. Once we delineate the tree crowns in our data, we can start to label them if we have information about their identification. If not, we can use some of the information to ID trees through an AI approach on our data. And then we can start to extract information on the health of each of those trees. You can just imagine how long it would take to go out on the ground and measure, particularly in impenetrable forest, the crown health of trees. It's a very difficult task as it is. It's subjective, it's qualitative. So we're developing these methods to make sure it's repeatable, it's quantified, and it's objective. So we look at that, we identify them, we extract the information. On the right-hand side there, you can see an example in a pine plantation where we've had a hailstorm go through. There's a pathogen called diplodia, causes blue stain in the wood of the trees. You have to harvest those trees very quickly before the blue stain is expressed in the timber for it to be viable on the market. So once that hailstorm went through, this client engaged us to fly over in our aircraft with ArborCarbon. We produced our data sets. We turned that data around within about a week and a half. We were able to put a point on every single tree, and each of those points were able to produce a scale of the vegetation condition index from the healthiest, which are those green dots, down to the least healthy, which are those red dots. So that told them very quickly where they should go out and where they should harvest, and they had the harvesters out there within a week removing those trees. This is another example of that vegetation condition index clipped to the vegetation above 3 meters in height. And you can see that the highest reflectance pixels are in the purple and the lowest reflectance pixels in the red. And of course, different species have different VCIs as well. If you can imagine, the light reflecting off a crown of a ficus is going to be very different to the light reflecting off the crown of a casuarina. So it's very important that we understand the species throughout an area that we're acquiring data for. And from that, we can start to benchmark the health of the trees. We can also do things like detect where there might be dead wood. So for example, what you're seeing there, the yellow boxes, it's a model that we've trained on our data to identify where either all the dead wood is throughout that area, or where the trees are deciduous. And this may be of interest, for example, if you're looking for a host for a particular pest or pathogen. So for example, something like Ace and a Gundo in polyphagous shothole. Once we delineate the tree crowns, you see on the left-hand side there, we've got the vegetation condition index again. So the purple pixels are highest reflectance in each pixel, the red being the lowest reflectance. We delineate the tree crowns. We can then extract what we call a mean value VCI for each of those crowns, which is what you see on the right-hand side. So that mean value is a mean value of every single pixel in that crown. And then we get that value for each of those crowns. So the high value there is delineated in the green, the lower value is in the red, and we're effectively benchmarking the health condition of every single tree in the scene. As you can see there, those casuarinas in the bottom left are lower in their VCI, and the other species through here, which are mostly plane trees, where there has been polyphagous shothole borer, continues to be, they're the ones we're interested in. So very quickly, we can get an idea about the benchmark health of those trees. And we worked with the City of Melville on this project. We've been acquiring this data for about 3 years now. Every year we acquire it at 1.5 centimeter pixels. So we drop the plane down very low altitude and acquire very high resolution data across this area, which is about 30 hectares throughout Applecross. Now, we won a national award last year for the best use of technology with the City of Melbourne for that work, which was very exciting. The real power in this data is the change in condition over time. We call this change detection. So what you see here on the left-hand side is the true color image. That is the standard red, green, blue that you see, very high resolution. What you see on the right-hand side here is the change, the 1 year change in the vegetation condition index. The blue pixels are an increase in value in the pixel, so increasing health or condition of the tree. The white pixels are stable. The black is unclassified, so it's not vegetation. But the real interest here are the red pixels. So anything that's red or pink, it's declined in that vegetation condition index over a 12-month period. And that tells us where we should go to target our efforts. It can tell us where full canopies have been removed, impacts from development. It can tell us where there's been pruning, like that one on the bottom left-hand side. And it can tell us where polyphagous shothole borer may have been impacting the trees and causing impact to their health. So this is the sort of work that we've been scaling across entire LGAs and beyond for a range of our clients. So just to sort of start wrapping it up around the work we've done and the technology we have. Fortunately, we've started out in Perth with some of the local government agencies and small clients, but then that expanded over to places like City of Melbourne and Sydney, as I said, and then beyond to New Zealand and the UK and Hong Kong. Been very fortunate to undertake projects in parts of Asia. We currently have a project in West Kalimantan working on natural capital, which is a DFAT-funded project. We have projects up in the Kimberley. So we have a diverse range of clients, as you can see there. And so many of them are government. We have a range of private clients as well. And we even still do a lot of work on the ground with, residential homeowners where they have sick trees, and we were asked to come in and look at their sick trees, provide advice around how to manage them, and even doing a wide range of tree audits as well as part of our work that we're doing. So, we're very fortunate to have some really amazing clients. And one of the reasons why I'm in Sydney now is we have a very large project for the New South Wales government, where 2 years ago we flew ArborCarbon over at nearly 500,000 hectares to map the canopy of all 33 LGAs in Sydney, and we're doing the 2-year repeat measure that's just started. So for this summer, so we'll be looking at the change in that canopy over 2 years. Which is a very exciting project for us, and New South Wales government's an amazing group and client to work with. So we're very fortunate. And more than that, we do amazing work. I would say I'm very, very proud to say that we have an amazing team, and that team is continuing to grow. They are diverse, and you can see a list of our team on here. And they range from people with backgrounds in, governance and the commercial side of things, forest pathology, also, biosecurity, AI, arboriculture, engineering, software development. We even have a visiting scientist from Sardinia in Italy with us at the moment, who's based with us for 6 months, Gabriele Satte, who's been working on Phytophthora impacting those amazing olive trees in Sardinia that are over 4,000 years old. So he's learning remote sensing with us, and then we'll be collaborating with him going forward to help the people in Italy. So I'd like to, big shout out to our team who are incredible, and they've all been involved in this work in one way or another. So appreciate you taking the time to listen to me, and I'm happy to answer questions.
Well, thank you, Paul. Great presentation. Even more I didn't know about, which is amazing. I'm sure there are questions, so let's open it up now. Don't forget, if you want to ask a question, you'll have to unmute your microphone. I think you've probably blown them all away.
Oh, I'll ask a question to kick off, if that's okay.
Please.
No worries.
Okay. Paul, it was interesting that you mentioned Adelaide were interested in controlling their giant pine scale issue because it could affect the forestry industry.
Yes.
That's obviously these pathogens would probably likely come in to the major cities first. So that's a pretty good reason for all local governments in major cities to be going to this extent, really, as I see it, because stop it in the cities. Well, that's what we're doing with the borer, of course, here in WA. I guess that's the plan. But I could really see that this is something they must all be doing.
Yeah, it is, Leisha. Thanks for the question, the comment. So it is. I'd say, this technology is opening their eyes, and some people are really big advocates. So people, for example, that have engaged us to do that work in Adelaide, they're very forward thinking, and the work in Sydney as well, and over in Melbourne. So they get it. I mean, it's great. They get it. They're willing to try new technologies, and in their eyes, in some ways, take a chance. Even though it's been proven in some areas, there's a lot of muck and mystery out there in remote sensing. There's a lot of people who've promised a lot over the years and not delivered, and it makes it hard for people like us coming in after them. But we've got, we don't overpromise. It's really important, and then we work with those who are willing to back us, and we start small. So absolutely, I mean, this is the sort of work that we have been talking to those sort of thought leaders about scaling nationally, particularly around the major capitals and the ports around the country. And that's, we're now sort of operating across that Sydney region, ACT, Melbourne, Adelaide, Perth. It's just about making sure that you're working with the right people and then scaling it to a bigger area. That's really important. So you're capturing it all. We just can't do it the old school way anymore. We just don't have enough people, boots on the ground. It's been shown that, it costs a huge amount of money. It's slow, and it's got a low success rate, and we're just not well equipped to do that, and so we just have to be trying different technologies to do it well.
More questions? I've got one, actually. I'd love to know, because as I mentioned in the introduction, I was blown away by what you can do. What are you going to be able to do in the future?
It's a really great question, John. It's a little bit hard to know, really. I mean, things are moving quite quick in this space, and I think remote AI in remote sensing is actually not new. So I think back to things like the random forest model, which is a convolutional neural network. That's AI effectively, and that's been around for decades. So we've been using AI in remote sensing for a long time, but we've been using it on coarser resolution data. We haven't had the processing speed in computers. That's all been ramping up and enabling us to do it faster. So at the moment we generate a couple of terabytes a day from the ArborCarbon. It's a large amount of data to process, and so that's been a major challenge. But that's going to get easier and easier, as we get more and more powerful computers over time. AI models are developing. I see a future when hopefully we won't need to be using traditional aircraft, to be doing this scalable work. It'd be nice to be able to do this sort of work either with electric or hydrogen powered aircraft, or with, UAVs that can scale across large areas. They exist at the moment. Ex-military UAVs, they exist, but it's very challenging being able to operate them over cities like we do. So, at the moment, our approach is the best approach. So, yeah, it's exciting. I mean, the satellites aren't there yet in terms of the resolution that we can produce, but, they're coming. They'll get there. No doubt the military have them. We don't have them yet. So, yeah, but they'll get there.
Mhm.
Thank you.
On a slightly more down to earth question, is the Battle of the Borer being won, and is that the same borer that is in generally around Australia, or is it a very specific one that they're struggling with in Perth?
Yeah, so the borer in Perth is different to what's around other parts of Australia. So it's only in Perth at the moment. They're very worried about it over in the East Coast. And it is the battle being won? I'd say it's probably being lost at the moment. So unfortunately, so it's, spreading probably further and faster than they thought it would. And, it's a real risk of us not being able to contain it. So requires possibly a different approach to what's being undertaken at the moment. So, but with there's collaborations happening with people in other parts of the world, California, South Africa, where it does exist, and so putting our heads together to see what we can do together to improve the way we manage it.
Mm. Thank you.
No worries.
I'd love to tell you we were winning.
Yeah.
But no, we just had the quarantine area further extended. So now it just about takes in the whole metropolitan area of Perth. Yeah.
Mhm.
It's significant.
Must be very worrying.
Yes, well, that's why WA is using your taxes, federal funding, to operate the control program. Yeah.
Good idea.
Are there any further questions?
Well, John, I just wanted to ask about about the borer. I think I read that they're no longer recommending trying to destroy the trees. Is that right, that are affected?
The current control method is to remove the trees.
And that hasn't changed.
Yeah, that hasn't changed.
And is there any anticipation that any sort of intervention chemically is appropriate?
About the same as buying a lotto ticket at the moment. Unfortunately. It's not for lack of trying, I hasten to add. It's certainly not for lack of trying. And they're still trying, but at the moment, there doesn't seem to be any feasible alternative. But let's not talk about the borer, because we've got Paul's ear. And although he is, I should explain, stuck in a car at Sydney Airport doing this, waiting for a flight, he's got plenty of time before the flame flies. So, any further questions, ladies and gentlemen? Well, if not, then it falls to me to give a sincere thanks to you, Paul, for the presentation. You can find ArborCarbon easily. Just type that into your Google search and you'll get there. And I know that Paul will continue to develop further and refine further these techniques that give us such an insight into a very important part of the world. So thank you for joining us all. And again, thank you, Paul.
Yeah, thank you very much.
Paul.
That's
Great.
fascinating.
Fantastic. Thank you so
No
much.
worries.
Fascinating.
Thanks everyone for attending.
And thank you, John, too.
Thanks, John. Cheers.
Yeah, wonderful. Thank you. Good night.
Okay. See you next week, Paul.
Thanks, John. Cheers. Take care. See you. Bye.
I'm just